The Center of the Data, our tutorial. In the Center of the Data lecture, we saw Allison produce graphs and summary statistics for two datasets, the skeletal remains dataset and the salaries of the New York Red Bulls. In this tutorial, we will learn how to use R to reproduce her results. Let's take a look at the skeletal remains dataset we will be working with. Notice that our dataset has variable names on the first row and a lot more variables than we need. Our main focus will be on the variable DG difference, which is simply the difference between the actual age and the estimated age of each skeletal remain. In R, we will set the working directory with the command setwd to specify where our data is located. We will name our dataset skeleton, read it in using the command read.table, and specify using header is equal to true that the first line in our dataset contains variable names and not actual data. It is good practice to view the data by just typing in the variable name skeleton, just to ensure that we have read in the correct dataset. It also allows us to check that we have the correct number of observations, 400 in this case. To have direct access to all of the variables in the dataset simply by variable name, we can use the command attach skeleton. We can now refer to our variable of interest, the differences, by just specifying the name DG difference. We can create a standard boxplot of the data using the command boxplot, specifying the variable we want graphed DG difference. The range is equal to 0 argument specifies that the whiskers should extend to the most extreme observations. The y-axis can also be relabeled to be more informative. For the modified boxplot, we can use the same command as above, removing the range is equal to 0 argument. Without that argument, the whiskers are extended to the first observations within the lower and upper inner fences. To construct your own boxplot, it would be useful to obtain summary statistics with the command summary, which will display the minimum and maximum observation, the first and third quartiles, the mean and the median. To double-check your work for the calculation of the mean, it would also be useful to obtain the sum of the data and the number of data values. We can do this with the sum and length commands. Then, the mean is just the sum divided by the length. We can also just use the command mean of the differences. For the 10% trimmed mean, we can specify in the mean command with the argument trim is equal to 0.1 that we wish to trim the top and bottom 10% of the observations. For the second dataset, the salaries of the New York Red Bulls, we will name our dataset NY salaries and just copy and paste in the 25 observations. To notice the extreme observations, we will produce a modified boxplot, choosing to graph the salaries in thousands of dollars. So the variable we will graph is NY salaries divided by 1,000, and we will label the y-axis accordingly. We can also obtain the median, the mean, and the 8% trimmed mean of the salaries. Note that for the 8% trimmed mean, we require an extra argument trim is equal to 0.08. Try working through some of the examples above and investigate for yourself the measures of centrality, such as the mean or median, and the effects of the extreme observations through the use of boxplots.